We're looking at points that lie inside, outside, or on a circle. So just remember, from the centre of the circle out to the very edge of the circle, which would be the circumference, that's always going to be a radius, okay, or the length of a radius. So in the first example here, right, C is the centre of the circle. A is a point and it lies inside the circle. So if the point lies inside the circle, well then the distance from the centre to that point would have to be less than the radius. Because if you think about it, the radius would go from the centre out to the edge like that. That would be the radius, or well, the distance from C to the point A, that is not a radius. It is just short of being the length of the radius. So if we're short of the radius, the point A would have to have lied inside the circle, right? That's where it lies. If the distance from the centre to the point A is equivalent to the radius, well, then that would tell me that the point A lies on the circle. And if the distance from the centre to the point A is greater than the radius, well, then it obviously lies outside the circle. So that's how we would determine whether something lies inside, outside, or on a circle. We will always compare the distance with whatever the radius is. Now, these three quick little formulae underneath that we're going to do. So if the distance from C, the centre, to the point A, if it ends up being less than the radius, we're inside the circle. If the distance from C to the point A is equal to the radius, well then we're on the circle. And if the distance from the centre to the point A is greater than the radius, well then we're outside the circle. This is how you will check to see if it is the case. These formulae. So if the point is inside the circle, if you sub the point into the equation of the circle that they give you, and if it ends up being less than the right-hand side, well then it's inside. If it's outside the circle, when you sub the point into the equation of the circle, if it ends up being greater than the right-hand side, well then it was outside the circle. And if you sub the point into the circle and it ends up being equal to the right-hand side, well then that point was on the circle. So we can use those three little equations or inequalities. They're inequalities, that's an equation. We can use those to determine whether the point lies inside, outside, or on the circle. Or alternatively, you could use your distance formula. You could get the distance from C to A and see is it less than the radius. If it is, it's inside the circle. Get the distance from C to A and if it's equivalent to the radius, it's on the circle. And then get the distance from C to A and if it's greater than the radius, well then it must have been outside the circle. So there's two ways of doing it. Distance or else knowing these three equations or these three inequalities. Example 1. The circle K has the following equation. X minus 4 to be squared plus y plus 1 to be squared is equal to 25. Write down the centre and the radius of the circle K. Well, it's in the HK format, so I'll put down the HK format. And then we link up minus h is equivalent to minus 4. I want to get h on its own, so divide across by minus 1. Then we'll get h is equal to minus 4 divided by minus 1 is plus 4. So I found h. Then minus k is equivalent to plus 1. I want to get k on its own, so divide across by minus 1. That will then give me k equals minus 1. So 1 divided by minus 1 is minus 1. Lastly, the centre then is hk. So 4 minus 1 is the centre of that circle. They also asked me to get the radius. So r squared should equal 25. Get the square root of both sides. The square root cancels out a square, so you're then left with r equals. The root of 25 is plus or minus 5. But remember, a radius can't be negative, so you take the positive answer. So the radius is 5 units. So that's part A. Part B, is that point, 7 minus 5, is that point inside, outside, or on the circle K? So we can do the formula method or we can do a distance method. I'm going to do the formula method because it's probably a little bit quicker. So given that our circle is in the HK format, these were the three inequalities to remember. If I sub the point 7 minus 5 into that circle equation, if the right-hand side ends up being less than 25, well then it means it's inside the circle. If my right-hand side ends up being greater than 25, well then I'm outside the circle. And if the right-hand side ends up being equal to 25, I'm on the circle. So I'm subbing the point 7 minus 5 into the equation of that circle. So label the point 7 minus 5 as x and y. So x is 7 and y is minus 5. And I am subbing in to that circle equation. So it's going to be 7 minus 4 to be squared plus minus 5 plus 1 to be squared. Now, if it equals 25, well, then I'm on the circle. If I'm less than 25, I'm inside the circle. And if I am greater than 25, I am outside the circle. So we start tidying it up. You can use your calculator. 7 minus 4 is 3. 3 squared is 9. Minus 5 plus 1 is minus 4. And minus 4 squared is 16. 9 and 16 is exactly 25. So that means the left-hand side of my equation ended up equaling the right-hand side of the equation. That would then tell me that I'm on the circle. So that point, 7 minus 5, lies around the circumference of that circle. Okay. You could also use your distance formula instead, and you could get the distance from that point to the centre and see, will it equal the length of the radius? If it equals the length of the radius, well, then it's on the circle. And we know it's going to be on the circle because we've just proved it this way. So the distance from the centre to that point should equal 5. Because that point lies on the circle. If you got a distance from the centre to that point and it was greater than 5, that would tell you it's outside the circle. And if you got a distance from the centre to that point and it's less than 5, that would tell you that that point must lie inside the circle somewhere. Okay, so this is the second method. I'm getting the distance from the centre to the point 7 minus 5. So I use my distance formula. I labelled my points x1, y1, x2, y2. I subbed in, tidied it up, and I get out a distance of 5 units. So from the centre to that point, it's 5 units in length. And it just so happened that the radius was also 5 units. So that's how I now know that that point, 7 minus 5, must be on the circle, because the distance from the centre to that point was equivalent to what the radius was as well. Okay, so we know that we are on the circle. So that's the second method. Either or, it doesn't matter which way you go. Second example, show that that point lies outside that circle. Okay, so this time they're being specific. They said show that the point is outside the circle. So if I use method 1, then my circle equations, if I am less than the right-hand side, I'm inside the circle. If I'm greater than the right-hand side, I'm outside the circle. But if I was equal to the right-hand side, I'm on the circle. Okay, so all I'm going to do is I'm going to label my point x and y, and then I'm going to sub that into the circle equation. So it'll be 2 squared plus minus 9 in a bracket squared equal to 9. 2 squared is 4, minus 9 to be squared is 81. 4 and 81 is 85. Well, 85 is much greater than the right-hand side. If I am greater than the right-hand side, that means I am outside the circle. And they asked me to show that the point lies outside. So it is correct to be getting a value greater than 9. If you got something less than 9 or equal to 9, you're obviously wrong because they're telling me that it is outside. I just need to show that it is outside afterwards. Alternative method would be get the centre of that circle, which is 0, 0. Then get the distance from 0, 0 to the point 2 minus 9. And whatever that distance is, if it's outside the circle, the distance from the centre to that point should be much greater than the radius. So obviously get the radius of this circle as well. R squared would equal 9. Therefore, R on its own will equal plus or minus 3, and you always take the positive answer. So the radius of that circle is 3. If I go and use my distance formula and get the distance from that point to the centre, which was 0, 0, you will get a value much greater than 3. And that will tell me that the point obviously lies outside the circle. Okay, go now and do the following 4 questions. So you can pause the video there. Off you go doing the questions and come back and correct the solutions in the next video.